Uh, Hello, everyone. Let me start from introducing myself. My name is Oleksandr Barabanov, like what was said, and I am a senior engineer at SoftServe, working primarily with backend and use .NET technologies. I'm particularly interested in code style, performance optimization, testing practices, and overall code quality, especially how we can make our test not just pass, but actually help us build better software. Today, I want to share some ideas and patterns that I have found valuable in writing clean, effective, and good unit tests. Many of them inspired by a book X unit test patterns by Gerard Messaras, as well as patterns from Microsoft and real world experience. I highly recommend reading this book. Although it was written back in 2007, it's still incredibly relevant even today. It covers a wide range of valuable content, from test smells and patterns to test organization principles, refactorings, testing strategies, and much more. So let's start. Why tests fail us and what we can do? We usually have unit tests in our projects, but for some reason they don't give us full confidence that everything works correctly, or that we can make changes without breaking something. Maybe you remember a situation where you were thinking about some refactoring, but were afraid to make a big change for fear of breaking something. What could that have happened? Why could that have happened? From one hand, tests exist, so we feel safe, but on the other hand, are they testing the right thing? Green tests aren't always meaningful tests. For example, we could have invalid tests, tests that have some smells, test fails, but the failure message doesn't help. For example, expected true, but was false. And why? We don't understand why. It just expected, and that's it. Also, we could find slow and heavy tests. This could be unit tests, for example, that interacts with database, file system, or external APIs. Some of tests could be hard to read and and that leads to we can hardly trust them. Tests that could be long, cryptic, or overloaded with setup logic. Also, some tests could have poor naming. For example, test one or check something, etc. Some tests also could have false positives or false negatives. It could be tests that pass even when they shouldn't be passed. It names false positive. Or test fails when everything is fine. This test could be named like false negative. All these problems are already well known, and the recommendation from the book X unit test patterns can help address them. Some of these issues are referred to as test smells. Let's dive into our first major topic, test smells. There are warning signs. Test smells is a warning sign that your test may be fragile, hard to maintain, or misleading. For example, you have tests, but some of them could be obscure. What does it mean, obscure test? Tests that are difficult to understand or too cryptic. just because it's green doesn't mean that it's good. This test creates false confidence because no one really knows what's been tested. Or some of the tests could be, let me show, fragile test. These tests break frequently due to minor internal changes. So, for example, we did refactor and 30 tests fail for no real reason. As a result, developers stop trusting the tests or stop running them altogether. Also, another type of test mail is erratic test. This test fails randomly due to timing, concurrency, or shared state. For example, test fails. Okay, let's rerun the test suite and hope for green. This leads to situation when we receive this false sense of success because tests are flaky and we can't trust them. Another type is mystery guessed. The tests that have high dependencies. For example, this test could access file system, environments, database, etc. They can, or tests can pass on the CI/CD environment, but fails locally, or vice versa. Another test mail over specific software. This type of tests are tightly coupled to implementation details. For example, if you change some of private method, then you receive, for example, 15 failed tests. As a result, tests no longer validate behavior, just structure. Another type of test mail is sensitive equality. It's like when asserts that overreact to small irrelevant changes. For example, test failed because some error message wording has changed. Such type of tests, they reduce team's confidence in test relevance because we change the exception message wording and test fail. In direct testing, these tests don't assert when they truly intend to. For example, they can pass when the system is actually broken. Or unrepeatable tests. Test outcome depends on order or external state. It works if you, for example, do some changes in your environment before you run it. It looks like an illusion of safety because result is not reproducible. So, when we notice test mails like this, it's a sign that the code needs improvement. But how can we make those changes? Let's dive into a few examples of some test mails and explore how to resolve them. And first example is obscure test. One of the type of obscure test is eager test. An eager test checks too many things in one test method. The tests just keep going, checking this, that, and everything else. And because of that, it's hard to see where the setup ends and the real test begins. There are many assert calls. Sometimes there are even code after the assertions. The test becomes long and confusing. As you see on the screen, we see that our test is too long. We have a lot of assert methods and even some code after assertions. Simply put, an eager test tries to test too much at once, maybe several methods or behaviors in a single test. That makes it harder to know what exactly is broken when test fails. Since multiple behaviors are tested together, refactoring any single method becomes risky. How we can resolve this problem? We can, first of all, split one large test into multiple smaller focused tests. Use only one assert per test. Create a custom assertion method to validate multiple properties, or use Flyent assertion library to verify all properties at once. Be careful, it's better to use Flyent assertion version 7, because starting from version 8, the library switched to a paid license, approximately $130 per developer per year for commercial use. So use this Flyent assertions library version 7. Okay, another test smell is another common issue is when the test includes irrelevant information. This happens when the test shows a lot of extra details about the feature, things that don't really matter for the behavior we're testing. As you can see on the picture, on the slide, our test shows a lot of logic that is not relevant to this behavior that we want to test. And those extra details can easily distract the reader from what's actually important. As someone reading the test, it's hard to tell which values really matter, which of these values really matter, what ones affect the outcome. That's a clear sign to the irrelevant information smell. Why is it a problem? It adds noise and hides the real purpose of the test. It makes the test harder to read and understand, especially for someone new. And even worse, it can mislead the reader. They might think that test is checking something else that it actually isn't tested. So always try to keep your test focused. Only include the setup and data that truly affect the behavior under test. And about this example, what's wrong in this example? The main goal in this test to verify that add item quantity adds a new line item to the invoice. Everything else is irrelevant in this context. So how to fix it? A better approach would be to use fake object or object mother pattern. You could also use the builder pattern or a factory method. It's up to you. The key point is keep the test focused and reduce irrelevant information. As you can see on the slide, we replace invoice creation with some method, and our test doesn't contain this a lot of irrelevant parameters that don't matter for us for this test. Okay, all right. We don't have time to cover all the test mails, but we also have another important topic to discuss. It's test patterns. So let's switch to discussion the test patterns topic. Before we dive into the test patterns, it's important to understand what makes a test truly unit level and what breaks the definition. That's where the unit test rules comes in. It's a concise list from the Mesaras book that defines the boundaries of proper unit tests and highlight the common violations that turn unit tests into something else entirely. As you can see in these rules, they mention Michael Feather, and he writes of object matter as you can see, Michael Fieser of Object Mentor writes this information. I've used these rules with a large number of teams. They encourage good design and rapid feedback, and they seem to help teams avoid a lot of trouble. A test is not a unit test if it talks to the database, it communicates across the network, it touches the file system, it can't run correctly at the same time as any of your other unit tests. You have to do special things to your environment, such as editing config files to run it. And the conclusion, he wrote, tests that do these things aren't bad. Often they are worth writing and they can be written in a unit test harness. However, it's important to be able to separate them from true unit tests so that we can keep a set of tests that we can run fast whenever we make our changes. So to avoid breaking these rules, our test should follow these key principles. It runs fast. It runs in memory. It runs consistently. It doesn't touch the database, network, file system, etc. It can be run independently of other tests. It uses test doubles to isolate external dependencies. So, if your test violates these rules, it's not really a unit test, even if it's named unit test.cs. It may be an integration test or a test that's too brittle to trust. So let's switch to discussing some test patterns. The first category I'd like to talk about is test double patterns. When writing unit tests, we often replace real objects with test doubles to isolate behavior, speed up execution, and test specific scenarios. Below are 5 common patterns, their purposes, and how they differ. Stub object returns hard-coded data for the unit under test. And mock objects, they verifies interactions. For example, what this method called, how this method was called. Useful for verifying some collaborations between objects. Fake object is this is a lightweight implementation. For example, in memory repository, when you replace database object with database context object with some maybe list or something else. Object mother, this is a centralized factory for with common test objects. The factory that could create test objects and we don't have to create them in our tests. And test data builder. This could be a Flyent builder class to create test objects. This builder improves readability and reduces irrelevant setup. Let's discuss some of them. And I want to discuss mock and stub because they are usually similar for us and we could confuse them because maybe everyone knows this third-party package, MockU. It has great possibilities for stubbing and mocking interface implementations, for example, database or HTTP responses. What is different between stub and mock? As you can see on this slide, could you find where is stub, where is mock? Stub, this one, its purpose to provide controlled responses to call. How it works? Just hard-coded return values for testing specific paths. For example, we see that we set up, like we provide a hard-coded data that will be returned by this method. So it returns a fixed customer. So it's tough. It doesn't verify interactions, just respond. And mock, the purpose of mock object, verify interactions between system and its dependencies. How it works? Pre-programmed expectations. For example, some method must be called once with specific value. And like you see on this example, we verify that some method with specific property, with specific argument was called once. Okay. The next test double pattern fake object is a working implementation of an interface that behaves like a real object, but is simplified and optimized for testing. It often includes shortcuts or simplified logic and stores data in memory instead of using external systems like database, APIs, etc. But it has also drawbacks. This fake object could have some implementation, and it may diverge from the real implementation, potentially hiding integration issues. And also, this object requires some effort to keep aligned with the real system's expectation. Another type is object mother pattern. Object mother pattern Object mother is a factory style pattern that provides real-made that provides a ready-made reusable objects pre-filled with default values for tests. It's useful when test objects are complex and need consistent, valid, and default values. For example, as you can see, our method just create some default methods with default values. Example to when we can use just example we have seen on the first slides when we replace a long logic with when we create invoice on the first slide. Okay, but what the benefits of this customer mother pattern? It sticks to dry pattern. Don't repeat yourself, and avoid repetitive object setup in each test. Also, it's easy to maintain. Because you have this object mother class, you have central place to change default test data. And also it helps readability. The purpose of the test isn't obscured by setup details, but it also has drawbacks. It can lead to overuse of overly generic object that not created to the specific test. For example, our object mother could create a lot of objects that are not required for our test. Also, there is some risk of tests depending on hidden assumption in the defaults. For example, if we expect something that was created by our customer mother or object mother pattern. When to use fake object or when to use object mother pattern. As you can see, for example, you need to replace a slow or flaky external dependency, you can replace it with fake object. If you need to create a valid but non-important test entities, for example, users, orders, configs repeatedly, then you can use object mother. If you want to have full control over dependency behavior during testing, fake object. If you want to reduce competition in test object construction, object method. If you are writing unit tests for service logic that depends on repositories or APIs, you can use both fake object and object method pattern. The next topic that I want to share is test structure patterns. There are quite a few other test patterns. Some of the structure patterns are, for example, test method. It's the basic unit of a test, well known as AAA pattern: arrange, act, assert. The book has old naming: setup, execute, verify, but the meaning left the same. This pattern defines a clear contract and readable structure. Fresh fixture. This pattern ensures each test gets a clean, isolated test context. Why it's important? It helps prevent tests from interfering with each other. And it's especially useful for reliable CI/CD pipelines, where tests might run in a parallel or in a random order. This pattern emphasizes that your tests should be able to run independently, no matter the order, or even if they run at the same time. Another type is test case class per class. One test class for each production class. It helps to keep test code organized and mirrors the system structure. Also, we could use custom assertion. This custom assertion wraps complex or repeated assertions in a helper, and it improves readability and diagnostics. We won't review all of the patterns, but one of that I think is very important is custom assertion. The custom assertion pattern involves creating your own helper method to encapsulate complex or repetitive assertion in your tests. Instead of writing long and detailing assert logic in every test, you move that logic into a single reusable method with a clear name that improves both readability and maintainability. In short, custom assertions make your tests cleaner, more expressive, and easier to maintain, especially when the same checks appear in many places. Let's look at an example. We have multiple assert statements in the one test. And when it fails, you might just see a message like expected file but was 4. And how can we make this test more readable? We can extract the complex assertion logic into a separate method. So the test contains only one clear assertion. This improves readability and makes file checks easier to understand. And the last but not least, Microsoft best practices. Of course, Microsoft has its own best practices that we should also take into consideration. Tests should be, for example, fast. It's not uncommon for major products to have thousands of unit tests. So unit tests should take a little time to run, even milliseconds. Isolated. Unit tests are standalone, can run in isolation, and have no dependencies on any outside factors, such as file system or database. Repeatable. Running a unit test should be consistent with its results. The test always returns the same result if you don't change anything between the runs. Self-checking. The test should automatically detect if it passed or failed without any human interaction. And timely. A unit test shouldn't take a disproportionately long time to write compared to the code being tested. If you discover that testing the code takes a large amount of time compared to writing the code, consider a more testable design. I want to tell you about only two principles. Have a look at the test method. Do you understand the purpose of the test method, of the test from its name? Test single. So Microsoft has a rule about test naming standard. The name of your test should consist of three parts. First part, the name of the method being tested. Second, scenario under which the method is being tested. And the third one, expected behavior when the scenario is invoked. For example, test single is better to name add single number, return the same number. Another problem is magic strings. Magic strings are hard-coded strings values in tests lacking context or explanation. They hinder readability, complicate maintenance, and obscure a test's purpose, forcing a deeper dive into implementation details. As you see on this example, we have a magic number 1001. What does it mean? So, how to resolve this? Make your goal to express as much intent as possible in your unit test code. Rather than using magic strings, assign any hard-coded values to constants. As you can see on this example, we replace this number with some constant, and now we understand what does it mean, this number. And finally, a minor feature I'd like to share with you is one interesting feature in the Visual Studio. Ask Copilot. This is AI-assisted test generation, specifically the Ask Copilot function in Visual Studio, which can significantly speed up unit test writing and refactoring. It can fix bugs, creating unit tests, refactor them, and much more. Let's check some examples. Let me change the screen I'm sharing. Okay, now you have to see Visual Studio. For example, we have this string calculator. By the way, I have created this string calculator also with Ask Copilot function. But anyway, we can press the right button and we can find this option Ask Copilot. What we can ask him. For example, we want to generate unit tests for this class. We can ask Copilot and ask him, create unit tests with X unit, for example, and press enter. Copilot will create tests for our class, and as you can see, it created a lot of interesting tests for interesting options. You could then create your, for example, class when you want, or just tap to accept and select where you want to save. But I prefer just copy and paste because I have to understand where I want to put it. So, and we have already a lot of unit tests just for several clicks. Also, we can refactor our tests. of course, after you create this generate automatically in test, you have to revise them and that everything is okay, and maybe change something, because sometimes copilot could create buggy tests. But I think it's a great improvement for us, for developers, to use this AI function to constantly creating this unit tests. For example, also about some refactoring tests. As you can see, this test have assertion method, use assertion method pattern. But for example, we want to replace it with flying assertion library, and we can ask this to do this for copilot. For example, we can ask him, please rewrite assert. We have only one assert using line assertion should be equivalent, and remove static method. And what we can see, copilot not only could create a code, generate a code, but it also could replace it in our code in our code file. We just press tab and that's it. As you can see, it replaced the code with function that we asked him. You can find how to use copilot in your own way, yeah, because how to use copilot could be like another topic. Let me share my screen. So today we have only scratched the surface. We covered just a small selection of the many test patterns available. If you found this helpful, I highly recommend diving deeper into XUnit test patterns book written by Gerard Mezaros and checking out the Microsoft test patterns documentation as well. Remember, patterns are not strict rules. They are tools, guides that can help us write unit tests that are clear, reliable, and maintainable. And finally, if you have your own patterns, experiences, or even test word stories to share, I'd like to hear them. Let's keep learning from each other. Thank you. If you have any questions, I'd like to answer them. Please, you are welcome.